paper 2, number 1, find fundamental triangle, find A's. So we're looking at this length here. Okay, so we've got this length, the angle in between them. So hopefully you realize that we are going to be using the cosine rule. Okay, so we're using this format because we're finding a length. Remember, when you're labeling your triangle ABC, we need to know the two lengths and the angle within them. And we know that information. So we've got the two. Oh no, why didn't I snip it? Lady. Okay, so we've got, oh, I can't see the numbers now. So we can say that AC squared equals 6 squared plus 10 squared minus 2 times 6 times 10 cos 100. Okay, chuck that in our calculator. Right, what I was doing there. Okay, so before we use the calculator, we need to check what mode it's in. We can see up here that it's in radians. Our angle's in degrees, so I need to change that first. So go to mode. Oops, too far. Enter. So I'm now in degrees. Now the only times that you need to check on radians and degrees is when you're using the sine, cos and tan buttons, and we are in this case, so that's why we need to check it. Alright, so then we can just chuck that in the calculator. So 6 squared plus 10 squared minus 2 times 6 times 10 times cos 100. Okay, and then we are, let's write that number though. So that's 156 point, I'm going to forget it. Okay, and then we are going to square root that number. Which gives us 12.5 to 3 figures. 12.5 centimeters. Okay, B. Angle BCA, BCA. So we're looking for this angle here. We would always try and avoid using a length that we've just calculated, but we're going to need to in this case. So maybe I'll choose a different colour. So if we're trying to find this angle, we know we've got this length, and we've got this angle, and we now have this length because we know it's 12.5. So we've got two angles, and then a question involving two angles and two side lengths. So this time we're using the sine rule. Okay, we're trying to find an angle, so we're actually considering it the other way up. So I would have, oh Lord, I keep forgetting the numbers. Sine theta over 6. So always start with the thing you're trying to find. So sine theta over 6 is equal to sine 100 over 12.5. Rearranging that gives sine theta equals sine 100 over 12.5 multiplied by 6. So sine 100 divided by 12.5 equals multiplied by 6. So okay, that gives me that value, but remember that's the sine of it. We need to find the actual value itself, so we would inverse the sine. So sine answer gives us 28.2. Okay, so even with my messing around, it only took 6 minutes. That's good. Right, consider the expansion of 10 plus 10, x plus 3 to the power 10. Write down the number of terms of expansion. They're nice easy ones. Remember that it's always one more than the power. So this would be 11 terms. Find the term containing x to the power 3. So going down to our formula booklet. Oh, here it is. So binomial theorem. So remember we are considering this situation. This is our general formula. So our n is 10. Now our, we'll discuss that in a second because I want to get the same method going for each time. X to the 10 minus r, and 3 to the power r. So that's our general rule of thumb. Then remember what we do is to consider which term we want. So we want the one with the 10 to the power 3. That only one of these has an x in it. X to the power 3, not 10 to the power 3. What am I talking about? So we want the one with an x to the power 3. Because this is the only term with an x in it, it means that r has to be 7 in this case. Hopefully you will see that. So this is 10, 7, x to the power 3, 3 to the power 7. So we're going to use our calc to find these numbers now. So we need 10, 7, so remember math. Probability, NCR, so we want 10, 7, that's the number 120, x cubed, and then we also obviously need to find 3 to the power 7. Oops, what was on? 3 to the power 7, 2187. There's no decimal point there. And so we're going to now do 2187 multiplied by 120. Gives 262440.